Now that we have configured all databases or Azure Service Bus and or Azure Service and an Azure function, the next step we're gonna continue with the history microservice. This one we're gonna configure the Azure Redis cache. The Azure Service Cache is a special database that is in Azure is a fully managed server and is an in-memory database. That means that everything is stored in RAM, which makes them very fast. If we go to the documentation, we can see that Azure Cache for Redis, it increases the throughput and it lowers latency. That means that it higher throughput means that it will enable 200 more requests and more data per period of time. Here, transactions per second. And latency means how fast it is to retrieve that information. So as you can see, 9x more in the throughput and x times faster for latency. To enable the Azure Cache for Redis, we need to go to the Microsoft Azure and let's go for Redis Cache. We create the server, select our subscription, we enter a name, it's gonna be Azure Redis. This is gonna be the DNS name, location east, and for this one we're gonna create a basic one. We don't need that much, we just need that for testing. So I think basic is the lowest. Then we go to the networking. This is okay, go to advanced, release version. We don't need tags. We just click on create and we wait. While this one is creating the server, we're gonna go to the history application. And we're gonna enable Redis here. So the first step, we need to add the library. Let's go to my NuGet package. And I already have this one, but you need to add them into the application, Microsoft extension caching Redis. Once you have this one installed, we need to set up the configuration here in the program to add the service. So in here, we're enable Redis into our services. With this one, we are getting the connection strings to connect to the actual server. So as you can see, I have here a name for config that are gonna be in our app configuration to get the connection string. So we copy this one and we create that into our app configuration. So let's go to the app configuration. And let's create a new key value. This is gonna be the name, and we need to wait until the deployment for our Redis is ready to get our connection string. So let's go back to where we were at. So we save this file, and we just go to the history controller. We need to inject the distribution cache interface to have access to the cache. Let's just implement this one. Let me change the name of the model. Delete the constructor. And I'm gonna just copy and paste here. So what I'm gonna do here is first we need a key. This key is the one that we're gonna looking for the information in our server. So each time we look for an ID, this is gonna create a unique key, and this is how we're gonna get access to the information that we're gonna store in the cache. Then the next step is actually going to the cache and see if that key already exists. And if it's empty, then we have to go to the actual database to get the information. And if this one is we find it, we need to store it into the data cache. So the way we do this is by copy and paste this part. So first we set up expiration date. So that means that in this example, we're just gonna set up 30 seconds for the information, and after 30 seconds, it is gonna go and remove the information from the cache, and next time the request reaches this endpoint, it will retrieve the data from the actual database. And no, first of all, I copy and paste this one correct. But this is the magic on the cache. If it exists, we just return the value from the cache. So actually this is a transaction. We keep a sync by the ID, and we just return the information from the cache. And this is basically what we need. I forgot that I needed to deserialize because it is gonna be a list. Okay, strict async. This is what we need. And we finish. We can remove this method here. And hopefully we finish with the setup, and the deployment of the Redis is already in progress. We need to wait until we finish to test that it is actually working. Now we're going to stop the service, add some breakpoints. Actually, it says that it's created already. Let me refresh the page. Still deploying it. We speed up applications with a distributed cache, complement database services like Azure SQL Database and Azure Cosmos DB by enabling your data type to scale throughput at a lower cost than through expanded databases instances. And this is exactly what we are doing. We have our Cosmos DB set up, but our application actually is gonna go to the Azure cache to get the information. We have also efficiently stored session data, communication between services as a message broker, use Azure Cache for Redis as a solution for implementing publish, subscribe, or queue architectures. Route real-time messages and scale up web communication frameworks such as Sign and Learn. Let's go to the pricing details. While we wait, Region East, pricing per hour. So we choose the standard, basic. No, actually, what's basic? The basic, it is gonna cost this much. Per hour. So it looks like it's really cheap, the basic one that we just created. We just need to wait until it's finished. So even the highest is not that expensive. $5 per hour per node. So there is an enterprise which is a little bit more expensive, $10 per hour. So in Premium Enterprise and Enterprise Flash, tiers are capable of hosting replica nodes in different availability zones, increasing availability and resiliency against a single point of failure. If the primary data center were to fail, the cache would automatically fail over the paired replicas cache in the matching availability zone. With multiple ASC redundancy and using at least 3 replicas, availability increases up to 99.99% for the enterprise tiers, which is almost, that is never gonna be down. Okay, now it's finished. It took 16 minutes to deploy. So once you finish, go to the resource. Let's go to the firewall to have access. Let's add a new rule. Access all. So this is just for testing, and make sure that for your environment just adds the range that you need to have access. Access key, we copy the primary key connection. This is the one that we need to add into our app config. and we should be ready to go. So let's go to the history. We go to Insomnia to send the request. It's not really. The cache was empty. It went to the actual service database, Redis service database, and it didn't find anything. So now it's time to go to the actual database, the Cosmos DB, get the information, store it in the cache, and return the information. So next step, we should see that the information should get from the actual Redis. Let's send it for 30 seconds. There we go. You can see that the information is gonna be getting from the cache. Let's go to Insomnia. And we have some issues. Because actually I have the wrong model. The model should be this one. Let's run this one again. As the information is deleted for this key after 30 seconds, it should reach the Cosmos DB instead of the Redis DB. Let's go again, send it. We go to the Cosmos DB database and we send a new one. And it should get information from the Redis database. Go to response. And we still have an issue. Let's see what's happening. Oh, okay, I see. My issue is here. Because I'm just saving the first value and not a list. Yep. And let's save this. Should work now. Let's run the query again. Get information from the database. We send back. Should get it from the Redis database. And we can see it's working now. And we finished setting up the Redis database, and now the history microservice is gonna be getting the information from Redis, which increases the throughput and lowers the the latency as we saw here.